Well, good evening, students. It's Mr. Rich. Welcome to another Sunday night Q&A. I'm going to be answering some questions that have been sent in. I did get a few from a few students, I think from AP Pre-Calc, at least one of them is, and I think from another class. I'm not sure which class it is. But anyways, let's get started. So I'm going to go ahead and pull the first questions in. We're going to start with some AP Pre-Calc. And most of my AP Pre-Calc students are in Unit 2, well into Unit 2. So that's going to be where we start. And it looks like we're doing arithmetic and geometric sequences. Now, I'm going to make sure before I get too far into this that I have my right microphone on. Let's see what I have here. Yeah, it's the right one. I think last week I had the wrong mic on and my audio, I think, turned out to be really terrible. All right, so let's pull the first question in. See if I can find it over here. There we go. No, that's not it. It's up here somewhere. I think it's right there. All right, here it is. So this is a geometric sequence, it looks like. So it says that the first four terms of a geometric sequence are given by G1 is, I'm going to say that's 1/5. It looks like it got cut off right there. G2 is 1, G3 is 5, and G4 is 25, which the following could be an expression for the general term of the sequence G sub n. Now, I'm going to use this formula, right? Hopefully your teacher has shown you that the nth term of a geometric sequence is GK times the common ratio raised to the n minus k, which gives us great flexibility in writing the general term of a sequence Gn, because that means that I can use any one of the terms here for GK so long as I put the index for that term. So when I look at my my options here I have a ratio, right? So as you go from one term to the next, we are definitely multiplying by 5. So the common ratio is 5. So we're probably going to disregard this one. We're going to disregard this one because that's an arithmetic sequence, so it can't be that one. And you know what? So is that an arithmetic sequence. So that's going to be our answer. Now let's make sure that this makes sense. Right here is the common ratio of 5, right here, R. They're using 1/5 for the GK, and 1/5 is the first term of the sequence, and therefore it's n minus 1. So that definitely fits this pattern right here that we've established. We're using the first term of the sequence G1 is equal to 1/5. So that 1 is going right in here for K. The 1/5 is going in there for G of K, and the common ratio is going to be 5. There you go. So that was our first question that came in. Here is the next one, also dealing with a geometric sequence. And before I do this one, I did want to mention of a couple of things that I do have coming up. We started our November SAT group. This week, I think, is going to be our third meeting getting ready for the November 8th SAT. But I do have another group that is starting at for the December SAT, and that starts on Thursday. I believe it's Thursday, October 30th. So yeah, so there you see the one for November, and then I think there's one for December as well. But that one is going to be starting towards the end of this month, and it meets on I think it's on Thursday nights. No, actually, it's Tuesday nights. It's starting on Tuesday, October 28th is when that starts. And then I wanted to also mention that if you are taking the ACT in February, Then I have an ACT group that is starting right after the winter break, about the second week of January, that's going to run all the way up to the February ACT. Now, if you're one of my students that's in St. Johns County, Florida, everybody is taking the ACT. No, that's incorrect. Is that St. John's now? I'm a little bit confused. I think it is. No, I think it is St. John's is paying. Yes. So St. John's is taking the ACT test in the third week of February, which would be the week after the nationwide test, which is going to be, I believe, the second Saturday in February. So I have it's a 7-week class that's starting mid-January. And then that's going to go all the way up to that test in St. Johns County on in the third week of February. So if you are interested in that, let me know. All right, so here is the next problem we're working on. Values of the terms of the geometric sequence Gn are graphed in the figure. Which of the following is an expression for the nth term of the sequence? And let's see if I do have some question options on this. Yeah, so here are the answer choices. I'll paste those in, and then we'll check it out. So we're given a graph of the sequence, and just a few comments on this. All right, one of the things that we want you to understand about geometric sequences is that they are what we call discrete exponential functions. They're not functions because they're not continuous. I suppose you could consider them a function, but they're just not continuous, right? We don't connect the dots here because the only input values that we allow are the natural numbers starting at 0 up through infinity along here. So we only allow those positive integer values plus 0 as inputs. Nothing in between, no fractions or decimals in between those numbers. So we can only plot the dots, right? But the dots will take the shape, if you were to connect them, they would take the shape of a smooth exponential curve. So there is this direct correlation between geometric sequences and what we call exponential functions. So very quickly, as soon as we get into lesson 2.3 in AP Calc, we're really getting away from sequences and we're going into exponential functions. All right, so anyways, what do we have here? We can see what the terms are, right? We have our outputs going from 8 to 4 to 2 to 1 and then to 1/2 and so forth. So we see it takes this characteristic exponential decay curve. So we know that this is going to be a geometric sequence, and we can see what the common ratio is. Because if we ratio two consecutive terms, 4/8 is 1/2, 2/4 is 1/2. So we can see that the common ratio is 1/2. When we look at our answer choices, we can only really consider those that have a common ratio of 1/2. So B is off of the list. That would have been an exponential growth, or it would have been an increasing geometric sequence. All right, so then what could we do? Well, remember, if we're using this form, Gn is Gk times r raised to the n minus k. We have multiple options on how we could drop this in here. We could say we're going to use the first term, 8. So we could say it's the nth term would be 8 times 1/2 raised to the n minus 1. Or if we use the third term, we'd say that Gn is the number 2, 1/2, and that would be n minus 3, because this output of 2 right here, that output of 2 goes with the input of 3, so it would be n minus 3. So we're just going to try to match this up and see which one could it have been. Well, if we look at A, 4 and 2, yeah, so that looks like a good one because we're using the second term and we're using the input of 4. So this looks like it's probably going to be our answer choice. Let's go ahead and eliminate these. This would be n minus 0. And the 0th term would not be 8, right? The 0th term, if you backed up to the 0th term back here, that would be a 16 up here, because you'd have to multiply that by 2 to get that term up here, 16. So in order for this to be an exponent of n, that would have had to have been a 16. So that's no good. And then, yeah, to get a 16, that would have had to have been n minus 0, or just n. So there's our answer there. Our answer is definitely A on that geometric sequence problem. All right. Thanks, Hadley, for sending those in. And then we've got a couple that Brandon sent in. Let's take a look at what class these are. So this is, oh, these are calculus questions. Yes. So let me pull these in. All right, Brandon, hopefully these aren't going to be too tough for me. Let's see. All right, so a little bit fuzzy. Let's see if I can get a little better shot of this thing. I think I can. Hold on. I think that's a little better. So here is the question. So we're given a function f of x is equal to secant x, and then we're told to get the limit of the function f of x minus f of pi over 3 over x minus pi over 3 as x goes to pi over 3. All right, so what are they wanting us to do right here? What they want you to see there, Brandon, is that is asking you to find the derivative of the f of x function at pi over 3. This is, they might as well have not given you that limit, and they could have just said, what's f prime of pi over 3? So what we're going to do is take the derivative and then evaluate it at pi over 3. But let me just quickly explain, like, how do I know, or how should you know that that's really the derivative? Because they want you to know that one of the definitions of a derivative of a function, we'll call it f prime of a. The derivative of function f at a is the following. It's the limit as x approaches that value of f of x minus the function evaluated there all over x minus that value. Because what happens is, if you take a look at this limit, as x gets close to a, this delta x, this bottom part here, gets very close to 0, and so does this. Let me show it to you. I'm going to take just a minute here and show it to you graphically what we're talking about. Right. So what we are talking about when it comes to derivative functions, if you take some random function, f of x, and you take a value here that we'll call a, and a value on the x-axis over here that we'll call x. This would obviously be the function evaluated at a. This would be the function evaluated at x. Now, if I calculate the slope of the line that would connect those 2 points on the curve, that's what we call a secant line. If I get the slope of that secant line, I would be doing a rise over run calculation. And so that would be the change in the y's. If you take a look at this right triangle, the change in the y's would be f of x minus f of a, right? That's like y2 minus y1, the rise between those 2 points. And then the run would be x minus a. And that gives me a slope. But what we want to do with the derivative is we want to find the slope, not of a secant line, but of a tangent line. So what I really want to do is I want this x right here to be moved. I want this point to get moved infinitely close to this. So the closer that I pull that point in along the curve and make it get closer and closer to a, so it's like super duper close now over there, you can see that now f of x would be down here. You can see that the closer that that point gets pulled into the point here at a, that this is going to get closer and closer to 0, and this is going to get closer and closer to 0. So how close do we let it get? We let it get infinitely close. I can't let it get all the way there, because then it would be 0 divided by 0, which is not really a quantity. So we just let it get infinitely close. And so that's why we take the limit as x approaches a. As this x value gets close to that value, that's going to give us the slope of the tangent line, which is the definition of the derivative. So they want you to recognize that that is what's going on right here, so that we really don't have to evaluate the limit. We know that the limit means take the derivative of that function. And you probably have memorized what the derivative of secant is. It is secant x times tangent x. And then we're going to evaluate that. Well, let's see what we have here. Maybe we don't have to evaluate it. No, we don't have to. All that we have to do is then stick in pi over 3. So our answer becomes secant of pi over 3 times tangent of pi over 3. All right. Brandon, I hope that helps. And if you are watching this, go ahead and post a note. Let us know that you are here. We do have a few students here. And again, my name is Mr. Rich. I'm taking your questions. If you have any questions you want me to work, any homework problems, you can post them over in the comment section. If you're one of my students, you have my email address, and you can send me an email to my email address, and I will work your problem. All right. Let's see if anything else came in. I think Brandon has one other question that he posted. And what I'm going to do once I run out of questions here, because I think Brandon sent me one other question. I am going to be doing some ACT, because we do have an ACT coming up this next Saturday, the 18th. All right, here we go. I see the question. All right. Uh-oh, Brandon, this looks like a tough one. I think you might be pushing me to my limits here. No pun intended there on the limits. Okay, so let's paste that in. All right, so this says, which of the following correctly shows the derivation of the derivative of cotangent x? Okay, I can honestly say I have not seen them do a sequence for a derivation of a derivative. Okay, but it would probably, like, if you're going to take the derivative of cotangent, you probably want to do it as a quotient rule, right? Because you could write cotangent. There's two ways we could rewrite cotangent. I can see, well, all of our answers, they did the same thing on the first step. What they did is they said cotangent is 1 over tangent, right? It's the reciprocal function for tangent of x. So we're starting there. And then let's take a look. Now, I will tell you this, that I can tell you this just doesn't look right? If you take the derivative of 1 over tangent x, you can't just say that we'll take the derivative of the bottom. That's not how quotients work. If you are taking the derivative of a quotient, you either have to convert it so that it's not a quotient and you use some other rule, or you have to use the quotient rule. So what they're doing here is we're going to get rid of A and B, because if you take a look at what they did on C and D, they've moved straight into the quotient rule right here on both of those. So my answer is going to be either C or D. Now I'm going to take a second and talk about the quotient rule, because I do tutor quite a few students in calculus, and I'm surprised that teachers sometimes don't teach students the saying that, at least it was pretty common amongst teachers when I taught AP Calc, to memorize the quotient rule. It's kind of it's a rhyme, right? So, and I use this, and I tell my students, this isn't just something that I tell students that are beginning to memorize. I say to know this rhyme and use it every time you're employing the quotient rule. And it goes like this: low D high minus high D low, square the bottom, off we go. So off we go. if you use that little rhyme there, it means the bottom times the derivative of the high minus the upper or the high function times the derivative of the low, and then you square the bottom function. All right, so let's see which one is the right one. So what they're doing, so low d high, so they're taking the low times derivative of the high. Let's see, no, sorry, right here, low, right, our bottom function is tangent x, times the derivative of the upper. Okay, there's a problem, right? That's supposed to be a minus. Let's see if the other one has a minus. Yeah, so it looks like C is going to be the answer here, Brandon, because I'm going to do low d high minus high d low, square the bottom, off we go. Okay, that's it. I don't really need to look at the rest of this. Obviously, the derivative of the number 1 is a 0. They replace that, so you do get negative secant squared right here over tangent squared. And then that simplifies, right? Because we know the derivative of cotangent would be negative, tangent is secant squared, so it has to be minus secant squared. Cotangent, derivative tangent is secant squared, and derivative cotangent would be negative cosecant squared. Yeah, so this will end up being negative cosecant squared if you simplified it further. But that's as far as you need to go on that right there, that they properly used the quotient rule. All right, I hope that helped you, Brandon. And I think that is all that has come in. So we're going to switch over and talk about the ACT. All right, so nothing else came in through email. Once again, if you have any homework questions, you can put them in the comment section, or if you are one of my students, send me your question in the comment section. All right, so here, what I'm going to do is I'm going to pull up an ACT practice test. And here it is. Now, what I'm going to talk about first is that this is what we would call the new enhanced version of the ACT. This is the one that they came out with. I guess they came out with this enhanced version earlier this year, or maybe late 2024. And by enhanced, we mean shorter, right? So the math section is now, instead of 60 questions, it is 45. Instead of 60 questions, 60 minutes, it's 45 questions, 50 minutes. It used to just be available, the enhanced version on the digital. But then this past offering that they did in September, the enhanced version was even on the paper version as well as the digital. Now, I think this fall is when they are switching everything to digital. I don't remember, honestly. I should probably know this, but I think that this October may be the first one that's fully digital, or maybe this is the last one where the paper's available, and then starting next year, they're going to go fully digital. So paper is on its way out on the ACT. It's already out, as you all know. I think the SAT, there are no paper versions. Everything has been moved to digital. Okay, but what I want to do is talk a little bit about the pacing on the ACT. If you've taken the ACT, you know that it goes from easy questions to hard questions towards the end. And I tell students that are usually in the in the low to mid 20s, and they're trying to get themselves into the upper 20s, close to 30, maybe low 30s. They really want to think about this test in maybe 2 sections. I tell students to think about it in terms of questions 1 through 30 as being the first part of the test. Okay, and so those are the 30 questions. You want to be almost perfect on those if you're trying to strive to get close to a 30. Okay, there may be 1 or 2 maybe that you get totally stumped on. You forgot something in geometry, or there's something you have forgotten, or maybe you make a minor mistake, but you miss 1 or 2, maybe 1 through 30. But when you get to 31 through 45, I mean, unless you're trying to get unless you're scoring well into the 30s and you're trying to get a perfect score, you just have to accept that you're probably going to need to shoot for maybe half of these correct, of these last 15. So you're trying to find maybe 7, 8, or 9 of them that look familiar enough to you that you could solve them and then not spend time on the rest of them, or at least find those easier ones for you. If you have extra time at the end, then go back and work some of the ones that you skipped over. But don't get bogged down and try to answer every one of those questions in sequence. It's just not going to happen. You've got to be very selective on which questions you are going to answer. All right. Now, what I'm going to do is, so anyway, so that's kind of what you want to shoot for. So if you've got 50 minutes on this test, then what I would say is you're going to be aiming for maybe 35 to 40 minutes working on the first 30, giving yourself maybe 10 minutes on these last 15 for you to find maybe 7 or 8 or 9 of those to work. And don't get stressed when you're skipping over problems, right? Just accept going in that you are not going to be answering all of these questions. The ones that are pure guesses that you did not even attempt to work, you have a guessing strategy for that, and that is you're going to pick the same answer choice, or at least the same position that you would pick, because they stagger those answer choices, A, B, C, D, and then E, F, G, H. But you want to, if you're going to pick 1 through 4, and you go straight down the line on your answer choices on the pure guesses. Okay, don't Christmas tree and go just randomly pick numbers. They randomly assign their correct answers, so you counter that by not being random and picking the same answer position for all of your guesses. So that is the strategy that I definitely would recommend there. All right, if you have any questions about the ACT, if you're watching this and you are going to take the ACT this Saturday, any questions, let me know, and I'll be happy to answer them. I've tutored lots and lots and lots of students on the ACT math section, only the math section, some on the science section, but 95% of my students, I'm working on the math. The other change that was made to the enhanced version on the math section is there are now only 4 answer choices instead of 5 on these all multiple choice questions, which is good. Puts it more in line with the SAT. But what I'm going to do is work a few problems from different domains. We'll start with maybe working a few geometry questions. So I'm going to scroll through here and kind of probably get through the first 10 easy ones. But let's start with a trigonometry question. One of the challenges on the ACT is that you don't have really, you're given no equations or no formulas other than ones that they might happen to give you on a particular problem. When it comes to trigonometry, at least in the first 30, you're really going to probably get by with just SOHCAHTOA. If you know the ratios for all 3 trig functions, you're going to be okay. So this says the sine of angle C is 2/3. So here's angle C. We know from SOHCAHTOA that the sine of an angle, in this case angle C, is the ratio of the opposite side length from angle C divided by the length of the hypotenuse. So when we take a look at this triangle and we apply that formula, for us, sine of C is equal to 6 over the missing side AC, which happens to be the hypotenuse. Now, the best way to solve this is just say, wait a minute, if my ratio is 6 over AC and they want me to find the length of that side, they did tell me what the ratio has to be. It has to be 2/3. So let's go ahead and set that equal to 2/3. And this becomes the equation that we're solving. And then the easiest thing to do here is to cross multiply, right? You can say, okay, if I've got 2 fractions equal to each other, 6 times 3, 18 is equal to 2 times side AC. So therefore, AC has to be equal to 9. That's the best way to solve that problem. All right, let me show you another one. This is involves percentages, are really more of an average kind of a calculation. So this says that so far this season, Sharita has made 46 of her first 60 free throws, which gives her a free throw average of about 76.7%. What is the minimum number of free throws she would need to make from now on in order to have a free throw average of at least 80%? Well, you could turn this into an algebra problem, but you don't have to, right? A lot of these problems early on in the test, you could do them by what we call back substitution. In other words, if you take a look at the calculation of her free throw percentage, 46 over 60, right? That's equal, apparently, they tell us, to 76.7%. Over here on my TI-84, if I try that just to make sure that's right. So there you go. So that's what they're telling me. Now, these are options for how many free throws she's going to have to make, minimum number, to get her percentage up to an 80%. Well, if they're looking for a minimum number, that would mean she'd have to like make all of the shots from here on out. So in other words, how many consecutive makes does she have to make in order to get the free throw percentage to 80%? What I'm going to do is I'm going to start with answer G and say, okay, if she hit her next 3 shots, the calculation would become 49 over 63. Because if she makes 3 more attempts, the 60 goes to a 63. And if she makes all 3, we get a 49. We then try that calculation, 49 divided by 63. That has boosted her free throw percentage only to a 77.8. So I'm going to jump all the way from G and try J right here and say, what if it was, instead of the next 3, the next 14? That would bump this up to a 60, and that would become a 74. 60 divided by 74 is 81%. So I'll bet you the answer here is going to be 10, because they're looking for the minimum number. That would make this 56, and 60 plus 10 is 70. Yeah, that's definitely going to be an 80% free throw percentage. 56 divided by 70, 80%. There you go. Now, is there an algebra method to that? Sure. What you could do is say, well, I'm going to let X be the number that she needs to make consecutively to get to an 80%, which would make 46 plus X over 60 plus X. And then I'm going to set that equal to 0.80 over 1. And then what I could do is I could just cross multiply and then solve that for X. I'm not going to do it here. It's very straightforward. If you want to try that on your own, go ahead and do that. All right, let's keep going a little bit further down into this. All right, number 16, in the standard coordinate plane, what is the midpoint of the line segment that has endpoints -5, 8 and 3, -1? So there's a midpoint formula that they teach you in geometry. It's this, right? Most students don't remember what it is, or they get it wrong and they subtract instead of adding these X's and Y's. So it's going to be that as your formula. But I really tell my students to not really memorize this formula. What you want to know on this test and on the SAT is that there are times when you have to find the middle number between 2 numbers. For example, sometimes on the x-axis, you may know 2 x-intercepts, 10, say, and -14, and you need to find the middle number between those two, say to find the axis of symmetry of a parabola. Well, to find the middle number between any 2 numbers, you just add them and divide by 2. You get the average number. If you add -14 and 10, you get -4. Divide by 2, it's -2. So I know that -2 is the halfway point between those 2 numbers. And that's really all you're doing with the midpoint, is you're saying, geez, what is the midway on the x's between -5 and 3? Well, if you add -5 and 3, you get -2. And then you cut that in half to take the average, you get a -1. And that becomes your answer G, because it's the only one that has an x coordinate of -1. If you want to try and make sure, that, hey, is this supposed to be 7 halves? Sure, take the y's, 8 plus a -1, 8 plus -1 divided by 2. Sure, that's going to be 7 over 2. That's the y coordinate of the midpoint. make sure that you understand how to calculate slope. Slope of the line that passes through those points. You should know as you go into this test that slope is rise over run, which just means the vertical distance between the 2 points divided by the horizontal distance. As a formula, it looks like this: y2 minus y1 over x2 minus x1. So I'll just take 7 minus 5, that's my y2 minus y1, and then 17 minus 1, 16, 1/8. One area that can trip students up on the ACT that will not trip you up on the SAT is the topic of matrices. I've never seen a matrix problem on the SAT. I kind of doubt I ever will, but you will see one or two questions on any given ACT regarding matrices. Some of the matrix problems you could probably figure out by your algebra instincts. And I'll show you what I mean, because I would kind of maybe figure you could figure this out, because it tells you a matrix is a group of numbers, right? We use them to solve systems of equations predominantly is what these matrices are used for. And they've given us two 2x2 matrices. They're 2x2 because I've got 2 rows and 2 columns in each one. And they tell you that matrix C is 2 times A minus 3 times B. What is matrix C? So 2 times A, if I told you to multiply that group of numbers by 2, your algebra instincts would probably tell you to distribute that 2 to all of the numbers on the inside, and that would be right. So the matrix 2 times A would be 6, 10, negative 4, and 2. And then if I took 3 times B, 3B, I'm going to get 3 times each of those numbers. So that gives me the matrix negative 12, 15, 6, and 3. And then what do they want me to do? They want me to subtract them. If you had to guess, how would you subtract this matrix minus this matrix? You would probably figure out to subtract the corresponding elements of the matrices. And you would be right. If you took 6 minus a negative 12, that gives you 18. 10 minus 15 is negative 5. I can stop right there. F is going to be the answer. That is matrices. There you go. All right, students, we've got about 15 minutes left, still working through an ACT practice test. Right now, we're looking at one of the enhanced version math sections of their practice tests, and going to look at maybe some of the more challenging ones here towards the end of the test. And if you have any questions about the ACT in general or test taking strategies on the ACT, let me know. The digital version, as I understand it, does not have a calculator. So you are responsible for bringing your calculator. I have been told that they do not have an online calculator like they do on the SAT. So you do need to take whichever calculator you're most comfortable with. I do tell students, don't go buy a fancy calculator to help you on the ACT unless you give yourself enough time to learn how to use it. The calculator you should use would be the one that you're most comfortable with. Now, there are definitely some things the ACT will do, or sorry, that the TI-84 will do for you on the ACT that your standard scientific calculator won't do. So you do have a bit of an advantage, not a real big one, but I would say if you do know how to use a TI-84, you'll have a slight advantage on the ACT on maybe 1 or 2 problems. Okay, here's question 25. It says, if both x and x over 3 plus x over 7 plus x over 9 are positive integers, what's the smallest possible value of x? Well, this is going to be another one that I would consider using back substitution. In other words, I'm going to start not trying to find x, but assuming that the first answer, which would be the smallest answer, the least possible, if that was my answer, would it meet the criteria? Well, first of all, if 21 is my answer for X. Well, then 21's an integer, so it meets that criteria. But when I put 21 in for these X's, I get a 7, and 21 divided by 7 is 3, but 21's not divisible by 9, so I am not going to get an integer right here. So if I take two integers and I add something that's not an integer, I'm not going to have an integer. So I think I kind of, as I'm working through this problem, I think I understand what they're wanting me to find. I need to find the smallest value of X that's going to be evenly divisible by all three of these denominators, so that all three of these would be integers. When I look at the number 27, 27 is divisible by 3, but not by 7, so I don't like that answer. 36, I think, is going to be the winner, because 36 divided by 3 is 12. No, that's not the winner, because 36 is not divisible by 7. So that's a loser. So it looks like our winner is going to be 63. 63 is divisible by 3. 63 is divisible by both 7 and 9. So therefore, that's going to give me an integer for both that number and the sum of all of those numbers right there. All right. Continuing on. Looking at number 26, which of the following expressions is equal to this for all positive real numbers a and b? Well, they want you to FOIL that. They want you to go ahead and multiply those two binomials using the same method that you would if they were something that you're more familiar with, like x minus 4 times x plus 6. You know to take this x and distribute it to each of those terms, then to take the negative 4 and distribute it to each of those terms, and then combine like terms. Well, that's what they want you to do here. So if we do that here, we take a times a gives me a squared. A times negative 2 root b would be a negative number, and it would be 2a root b. I move now to the root b, and I'm going to distribute that. That gives me plus a root b. And then when I multiply this, root b times root b is just b, right? It would be the square root of b squared, which is b. So this would be a negative 2 times b. Keep in mind that you got to watch for the signs, right? This is a positive times a negative, which makes this answer right here a negative 2b. When I look at my answer choices, I need to have an a squared and a negative 2b. So it looks like G and J are the possibilities here. It comes down to, what do I get when I combine those terms? It's going to be a negative 1a root b. Now I notice the only difference between these answers is that middle term. So it's probably not a bad idea to go back and make sure that I got the signs right on both of those. Because if this was a negative a root b, then it would have been J. But right now I'm thinking G is the answer. But let's go back and make sure that this is a positive a root b. Yeah, right here. A positive a times positive root b gives me a positive a root b. There's my middle term. Now I'm convinced G is my answer right there. Okay. Moving forward. All right, I think I want to talk about this one here. It says the track for a model railroad display is set up as two circles that are tangent to one another and have diameters of 30 feet and 50 feet as shown. The engine of the train travels at a constant rate of 75 feet per minute. To the nearest minute, how many minutes does the engine take to go in a figure 8 pattern around the entire track one time? So the first thing we have to do, well, we have to recognize that this does involve the following formula. Distance is rate or speed times time. Distance is speed multiplied by time. Because this involves how fast it's going, 75 feet per minute. There's the speed. It involves time. They want me to find the time. So they want me to find time. They've given me the speed, but I need to calculate the distance. And a figure 8 pattern means that this train is going to travel both of the circumferences of this circle. So I have to find the total circumference of both circles, add them together, and that will be the distance the train travels for this formula. So this requires you to know circumference is 2 pi r. And the radius of this is 15 feet. The radius of this circle is 25 feet because they've given us the diameters. So what I'm going to do is do 2 times pi and times 15. That gives me, that's the distance on the 30-foot track. Then I'm going to do 2 pi times 25. I get that. Now I'm going to add those two together. So I'm going to go up and grab that one, plus arrow up and grab that one, hit enter. That's my total distance right there. So now when I go to this formula, they want me to find time, which would be distance divided by speed. That distance is the 251.327, which is already in the calculator. So I will scroll up, highlight it, hit enter, and then I'm going to divide it by 75. And I get 3.35. They want me to the nearest minute. That would be minutes. Nearest minute would be 3 minutes, round it down to 3. Now it's probably worth looking at the units of measure here. All right, it is feet for the circumference or for the diameters and therefore the circumference. The speed is feet per minute. So I've got consistent units with feet and minutes, and they want me to calculate minutes. So I'm good just to take the sum of those two circumferences and then divide by the speed, and I will get the units of minutes. And there's my answer, the number 3. All right, let's talk about logs. This is one area that you'll see towards the end of the test. This is question 29. So we're getting close to that area where I'm saying from about 31 to 50 for students that are scoring in the 20s, trying to get themselves to a 30, kind of that cutoff point. And you're getting close to that. Logs are ones that do trip students up. So let me just remind you of a few things about logarithms that might help you on the ACT. When it comes to logarithms, you want to be able to convert between exponential equations and their equivalent logarithm form. Now, the way that we do that, just to remind you from your Algebra 2, if I showed you this exponential equation, and I said convert it into its logarithm equivalent. Well, there's two ways to think about it. I'm going to just show you one of the ways that we teach you to think about this. Well, this is the base of the exponential. So if you move the base of the exponential over to the other side, it will become the base of the logarithm over there. That exponent will stay put, and then the 52 becomes what we call the argument of the logarithm. So that's how you convert from an exponential to a log. But that also means that you can go from log to exponential. And so if someone presents you a logarithm, you can get it back into its exponential equivalent by taking the base of the logarithm, moving it to the other side. It becomes the base of an exponential. That becomes the exponent. And then you leave behind the argument. And now you've just converted it back into its exponential form. So what I would say in this problem, one of the ways you can get this pretty easily is do that conversion. If you take this base of the logarithm, which is an x, and you move it to the other side of the equation, and then that becomes the exponent, leaving behind the 1/25th right there, then you can easily solve this. A couple of ways you could solve it. If you raised both sides to the -1/2, you could do that because -2 times -1/2 is 1. That solves for x. If you don't know what 1/25th to the -1/2 is, you could then do that on your calculator. You could put 1/25 and raise that to the -0.5 power, and it's going to give you that. Okay, what did it not like? Oh, it didn't like the fact that I used a minus sign, excuse me, a subtraction rather than a negative. That's what happened right there. See that? So if I change the minus sign, the subtraction to a negative, it'll be okay. And my answer is 5. Okay. Now, there is one other thing that you can do. A lot of you remember, if you do have a TI-84, that there's something called the log base function. If you hit the math key on your TI-84 and you scroll to the bottom, there's a function log base. And you could have used back substitution here. You could have said, well, I'll put a fraction of 1 over 25 inside the logarithm, and I'll just try these different values of x from which they're wanting me to choose. So if you start with 5 and put log base 5 in there, you get the -2 that you're looking for. Okay, there are other better ways of solving this using logs and exponential properties. I'm not going to go into those, but anyways, those are just a couple of ways that you could solve that logarithm problem. Now, when you get into question 31, 32, and so on, you're looking for problems that you think you could easily solve or that are reasonably solvable. I'll give you an example of one that you might come across and it might scare you off, right? If you look at this and you realize, I'm not very good at trigonometry, I don't remember some of the geometry things, and then you see this, that might be one that you want to skip. Okay, if you're good at trigonometry and you know how to use the Pythagorean theorem and sine, cosine, and tangent, maybe that's one that you want to work on. All right, so here's one that I'll show you that really stumps. I would have to imagine this is going to stump about a minimum 75% of the test takers. It's question 38. So it talks about the average of 10 test scores being X. The highest score and the low score are removed. The average becomes Y. Which the following is an expression for the average of the highest score and lowest score? So most students, upon reading that, immediately say to themselves, I have no idea where to even start to find the average of the high and low when I don't know any of the numbers involved in the data set. It's fine. Spend 10 seconds to realize, you know what, I'm not going to answer that, and then go to the next question. Write it off. If you had extra time at the end and you've done all the other problems, okay, sure, come back and try to make some sense out of this. But let me show you, we just got about 3 minutes left, so let me show you what's behind this problem and how you might reason to a solution. It says that the average of 10 test scores is X. And when the highest and lowest score are removed, the average becomes Y. So what I would be thinking is this. I'd be saying, well, I would be adding 10 numbers, and then I would be dividing by 10 to get the average. And they're telling me that that average is X. Well, one thing I know about averages is that when I take the average value of a set of numbers and I multiply it by the number of values, I do get the sum of all of the numbers. So one thing I know is that if I were to look at what the sum is of all 10 numbers, it would be equal to 10 times X. Now, there is a low and there is a high. I don't know what they are, but nonetheless, there's going to be a low and a high. If I remove those like they tell me to do, that would give me only 8 numbers left. And I would be dividing that by 8 because I removed 2 of them from the data set, and they told me that that is Y. The average is Y after I remove the low and the high. Well, what would be the sum of those 8 numbers? The sum of those 8 numbers would be 8Y. So I'm just going to erase that division and multiply the Y by 8. So what I have is this. The sum of all 10 numbers is 10X. The sum of the 8 middle numbers after the low and high are removed is 8Y. I don't know if you can see this, students, or if it comes to your mind, but if I subtract those 2 equations, these middle 8 will get subtracted out by those middle 8, and it'll just leave me L plus H, right? These other 2 numbers up here, L plus H would be equal to 10x minus 8y, because I would be subtracting both the left and right hand sides. And then how do I find the average of the low and the high? I would divide both sides by 2. That would be the average of the low and high. That would be my answer right there. Now, if you look at that and you say, you know what, Rich, I see how you did that. I would have never thought of that. Okay, so that means victory for you on that problem is to not spend more than 10 seconds before you realize not going to work that problem. And that's a victory for you, and you keep moving on. The failure is to be stubborn and then try to figure this out, spend a minute and a half, and realize you're going to guess anyways. So that's what you have to, that's how you have to look at those last 10 problems on the test. All right, well, I think that's going to be it, because it is 9 o'clock. So moving forward, if you come back next week, what I am going to do is I will answer any homework questions that you send in. Then after I get done with those homework questions, or if I get no homework questions, I'm going to go straight into doing ACT and SAT test prep. So if you want to come and take a look at some SAT problems, and I will give you some good advice on how to tackle some of the more difficult problems that you might see on either test. Or if you're prepping and you have some questions that you want to ask me, come back next week. I'd be happy to answer those questions for you. All right, so I think we're going to call it a night, everybody. Here in our school districts, tomorrow is a holiday, Columbus Day, and so students are out of school. So I hope you have a good day off and a good restful day. And I will see you all back here next Sunday, same time at 8 o'clock on Sunday, the 19th of October. See you, everybody. Bye.